Good morning, students. In this lecture, I am going to solve a question of exercise 10.3. The question is, if two circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of the common chord, right? So students, this is the one of the question, very important question of exercise 10.3, third question. So let us prove this question, solve these questions. So if two circles intersect at 2 points, prove that, means before proof what is given, that is the given condition. That means consider two circles figure. If two circles intersect at 2 points, so here are two circles, so they intersect with each other at 2 points. Let A and B are their point of intersection, while O and O dash are their centers. Okay, so what the question is asking, prove that their centers means joining these two points, a line segment is formed. So prove that their centers lie on the perpendicular bisector of the common chord. So if we join AB, a chord is formed that is common for both the circle C1 and circle C2. AB is the chord that is common for both the circle. Chord means the line segment joining any 2 points on the circle. So AB is a line segment which is common for both the circle C1 and C2. What are the given condition here? We write here AB is the common chord for the circles C1 and C2 having centers O and O dash. And what do we prove? What are we going to prove? Their centers lie on the perpendicular bisector of the common chord. Yani O dash lies. O dash lies. The centers O and O dash. Center O and O dash. O dash lies. The line joining is O dash, line segment. O dash lies the perpendicular bisector of common chord AB. We just prove it. That is what we prove. AM equal to BM and angle OMA equal to angle OMB. These two implies O dash lies the perpendicular bisector of common chord. So some construction is required here. Construction: join OA, OB, O dash A and O dash B. So we write here join OA, OB, O dash A and O dash B. Right, students? Now proof. Proof here. Proof. Here we start proof. Okay. So first take two triangles OAO dash in triangle OAO dash and triangle OBO dash. We are just comparing these two triangles OAO dash and OBO dash. So what you conclude here? OA is equal to OB. We write OA equal to OB. Then O dash A equal to O dash B. O dash A equal to O dash B. Why these two are equal? Because the OA OB are the radius for the first circle C1, while O dash A O dash B are the radius for the second circle C2. So what you write here as radius. Okay, and third one is O dash. Look at here is the common side for both the triangles OA O dash and OB O dash. O dash equal to O dash as common side. Common side. Okay, bachcho. So what you conclude now? These two triangles are congruent by side angle side congruency, by SSS congruence rule. Congruence rule. Right, students? So for easiest method, you know that for easiest method I am saying that angle 1 is equal to angle 2. Why? O dash A equal to O dash B. So after congruency, the angle opposite two equal sides are equal. We just need these two. So that is why I am taking this one. This named as angle 1 and this angle named as angle 2. It is easy for you. So angle 1 is equal to angle 2 by CPCT, corresponding part of a congruent triangles. Okay, bachi? To equal these two triangles, to equate these two angles, angle 1 and angle 2, we just compare these two triangles OAO dash and OBO dash, and these two are compared, means these two triangles are congruent by side congruence rule. Now again compare two angles. Now again we write in triangle OAM and triangle OBM. Now let us compare triangle OAM and triangle OBM. So what are given conditions here? OA equal to OB as radius. So we write OA is equal to OB as radius. ठीक है, construction we write here. Then angle 1 is equal to angle 2, already proved above. Third one is OM. OM is equal to OM as common side. These are the common side. So now in triangle OAM and triangle OBM, OA side is equal to OB side as radius, angle 1 is equal to angle 2, already proved above, and OM is common for both the triangles, so that these two triangles are congruent by side angle side congruency. So that implies triangle OAM congruent to triangle OBM by SSS SAS, side angle side congruence rule. And after congruency, what we conclude? AM is equal to BM. 1 is equal to angle 2. So the side opposite to these two angles are equal. So AM is equal to BM. And also OMA angle. OMA angle, this angle is equal to OMB, this angle. So and OMA angle is equal to OMB angle. These are due to CP/CT. Now already we prove here AM is equal to BM, but we just prove that OMA equal to OMB equal to what? 90 degree, because we prove that O dash lies in the perpendicular bisector of a common chord. So, okay, so we just prove it, these two are equal. Now we prove that they are 90 degree also. So look at here students, AM is a line segment, OM lies on AB. So positively OMA angle, the sum of OMA angle and OMB angle is what? 180 degree, linear pair angles. So what you write? Now OMA angle plus OMB angle, the sum of these two angles is 180 degree as linear pair angle, right? As these two angles are equal, so what you write in place of these two? Twice of OMA equal 180 degree. We write here as OMA is equal to OMV. Okay, so OMA is equal to what? 180 by 2, that is equal to 90 degree. So you write, we conclude that here angle OMA equal to angle OMB equal to 90 degree. So what you already proved here? First we prove AM is equal to BM, and then we prove that OMA equal to OMB. AM is equal to BM, OMA equal to OMB equal to 90 degree. So we at last conclude that the centers O and O dash lies in the perpendicular bisector of the common chord AB. That means O dash lies in the perpendicular bisector of the common chord. So hence O dash lies in the perpendicular bisector of the common chord AB. Hence proved. So this is one of the most important questions which we already proved here. Thank you, students.